Hello everyone, welcome back to our channel. Today we'll be solving a LeetCode question, first bad version. Let's read the question first. You are a product manager and currently leading a team to develop a new product. Unfortunately, the latest version of your product fails the quality check. Since each version is developed based on the previous version, all the versions after a bad version are also bad. Suppose you have n versions 1 to n and you want to find out the first bad one, which causes all the following ones to be bad. You are given an API which returns Boolean value is bad version, which takes the integer version, which returns whether version is bad. Implement a function to find the first bad version. You should minimize the number of calls to the API. Now, the question is you have n versions of a product. Okay. We have n versions of the product. So version 1, version 2, version 3, 4, 5, 6, and so on up to n. We know that the last version n, this is bad version, right? And every version is based on previous version. So it is possible that version n is bad because version n minus 1 was also bad, right? So we started with a good version. In between, some version became bad, and consequently, all the versions after that version are bad. So we need to find out the first version which was bad. We started with, we had a good version, we developed on it, we again had a good version, and somewhere a version became bad. Then all the subsequent versions are also bad. Now we need to find out the version number which is first bad, right? So how will we solve it? We are given a function here is bad version. If I pass version number here, it will return true if the version is bad and false if the version is not bad. Now I want to find out which version number is first bad. So the brute force approach is very simple. We'll start with version 1. We'll pass it to this function and it will say, let's say the version 1 is not bad, so it will return false. Next, I pass version 2. Let's say version 2 is also not bad, so this function will again return false. Then I pass version 3. Let's say this is also not bad, so it will return false. Next, I pass 4. Let us suppose the fourth version was the first bad version. So this function will directly return true now, and this will be my answer. Right? So up to the first bad versions, I'll need to pass all the versions starting from 1. And whenever I get true, this means that is the first bad version. Let's say in the worst case, version n is bad. So how many function calls will be made? N function. In this approach, let's calculate how many function calls are made. In the worst case, if only version n is bad, we need to call this function n times. So how many function calls are made in the worst case? N function calls, right? Function calls are n in the worst case, right? In this question, we need to minimize the number of function calls. So let's see a different approach. We have version 1, version 2, version 3, 4, 5, and so on up to n. And we are assuming fourth version is the first bad version, right? So this is good version, this is also good, this is good, and all of these versions are bad. Now, if I call is bad version on all of these versions, this will return true from here and false for this. Can you see a pattern here? So whenever we have a range of answers and this kind of pattern is formed, we can always use binary search on answer. So here we'll be using binary search on the version number, right? What is the minimum version number? 1. So we'll take low as 1. And what is the maximum version number? N. So we'll take high as n. So let's say n we have here is 5. And let us say 4 is the first bad version. Okay. So low is 1 and high is 5. First we'll calculate mid. What is the value of mid? 1 plus 5 by 2. This will be 3. Now we'll call the function for 3. So I'll check is 3 bad version. So this is the first function call. This is the first function call. So is 3 a bad version? No. So this will return false. So now if this is not a bad version, this means all the versions on the left side of this were not bad. The first bad version is towards the right. The first bad version will be after this. So we'll shift our low to mid plus 1. So here I'll have my low as 3 plus 1, 4. And high will remain same. High is n, that is 5. Now what will be the new value of mid? 4 plus 5 by 2? 4. Now mid will be 4. So again we will be doing the second function call is bad version 4. So we'll check if 4 is the bad version or not. So 4 is bad version. So this function will return true now. So now I know that 4 is a bad version. There can be a bad version previous to it as well, right? It's not necessary that whenever we hit true, it's the first bad version. We can hit true anywhere here, right? For all the bad versions, the function call will return true. So we need to check the versions prior to it as well. So now we will shift our high to mid minus 1. So now high will become 4 minus 1, that is 3. And what was the value of low? Low was 4, high is 3. So the condition for binary search is false. So this will stop it. So what is our answer? 4. So whenever we hit true, we'll store that version in an answer variable, right? Now let's try to write a pseudocode for this. So we'll take low as 1 and high as n. We'll apply the while loop while low is less than or equal to high. We'll also keep one answer variable to store the final answer, right? In the while loop, we'll first calculate mid value, right? You know the formula for mid. Then we'll check if mid is a bad version. We'll store this in answer because this can be our first bad version, and also check the versions prior to it. So we'll also shift high to mid minus 1. And if it is not a bad version, that means the first bad version is towards the right side. So we'll shift our low to mid plus 1. So in the else part, we'll write low is equals to mid plus 1. After the while loop is over, we can simply return answer. Now, how many function calls are made here? Since we are using binary search and there are n versions, so log n function calls will be made here. So log n is the number of function calls because every time we are reducing the number of versions to half. Now let us see the code. You can find all the codes in C++, Java, JavaScript, and Python in the link given in the description below. Let us see the C++. Here we are initializing low to 1 and high to n, and then we are using the binary search loop. So this code is exactly same as the pseudo code we just studied. That's it for this question. Thank you very much for watching. If you like the video, please do subscribe.